Good morning, DSST students, and welcome back to 3.2 Physical and Chemical Change. My name is Mr. Ducharme. Let's get started. You've already completed your read to learn, so you should have picked up the main information about what a physical and a chemical change are. We're going to be learning those two new vocabulary words today and then using it to analyze chemical equations to figure out a little bit more detail about what actually is happening. So we are going to start in our guided instruction. The definition of a physical change is a change where a material changes shape or state, but no new substances are formed. Another way of saying that is there's no bonds broken or bonds created. Remember, chemical bonds are what hold together two atoms. Atoms come together and are held together by bonds because it makes both of those atoms happy. It's favorable energetically. Now, we're going to learn way more about that later in the year, but for now you just need to know that atoms come together, they are stable, they're happy when they form bonds. However, sometimes you can put two compounds in the same space, and they break bonds and then meet up with a new chemical and form a new bond. Okay? So in a physical change, no bonds are broken, no bonds are created. So what that means is the compound you start with is the compound you end up with. The reactant compounds are the same as the product compounds. An example of this is an ice cube melting. We start with solid water, H2O, two hydrogens and oxygen bonded together, and we end up with liquid H2O, liquid water. Two hydrogens are still connected to an oxygen. No bonds are broken, no bonds were created. All that changed was in solid water and ice, the compounds are moving slowly, they have less energy. And then in water, they're moving faster, they have more energy, so they're moving around quickly. So in a physical change, you end up with the exact same thing you started with, the compounds are the same, no new bonds are made. However, in a chemical change, that is when a new substance is formed. So the bonds had to be broken, and they meet up with new atoms or new elements, and they form new compounds. So new bonds are created. Okay? Now, we can't see what's happening with atoms and compounds. They're just too small. They're microscopic. And so there's some clues that we can see and observe as scientists to know if a chemical or physical change happened. So the first thing we're going to go through is clues that a chemical change happened. The first clue is that a new gas is produced. An example of this is you mix baking soda and vinegar. If you mix baking soda and vinegar, all of a sudden bubbles start to form. That's carbon dioxide, which is a new compound that's made, and you see it as a gas that gets created that bubbles off into the air. Second clue is the forming of a precipitate. Now, I'm not going to talk a lot about what that means. You're going to learn more about that in high school chemistry, but essentially what that means is if you dissolve or mix two things together and all of a sudden a new solid forms, that would be a clue that a chemical change happened. Number 3, this is a really common one, a color change. You take two clear liquids and all of a sudden they change color and are purple. That's a clue that some new compound that has a new property of being purple was created. Number 4, the release of energy as light or heat. And that's without me adding heat or light. So for the example of this, if you've ever used a hand warmer on a really cold day, maybe you've gone skiing or hiking or snowshoeing, and it's been really cold outside. If you take a hand warmer, normally it's not hot, but when you shake it, you're mixing the compounds together, a chemical change happens, and all of a sudden heat is created. That's a piece of evidence that a chemical change occurred. The last one is the production of a new smell. If all of a sudden something starts to produce a new smell, that's a clue that a chemical change occurred. Physical changes are more straightforward. Something just changes changes shape. So for example, if I take a piece of metal and I bend it into a new shape, it's still metal, it's still the same thing, just in a new shape. It changes the size of something. I take a piece of wood and I cut it in half. Still wood, it's just a different size. I have different mass, but same exact compound. Change in form, that's similar to what I've already said, and then change in phase or change of state. That'd be like changing a solid piece of water, ice, into a liquid piece of water. Okay, so that would be a change in state. Let's go ahead and apply this to some guided practice. In video number 1 you watched for the Explore section, we had sugar and sulfuric acid. Okay? And when they were mixed, all of a sudden, something new was created. Let's go ahead and watch, and we're going to try to write down clues that a chemical change happened. So what can we observe that makes us think it might be a chemical change? And clues that it might be a physical change. We're going to keep track of those. We're going to rewatch the beginning part of the video and see what we think happens. So first, they're pouring sugar in. Sugar is a white solid. Then they're going to go ahead and pour in the sulfuric acid. I'm going to go ahead and pause right there so you can see the acid looks like it's actually a clear liquid as it gets poured in. Now that's a little bit tricky because as we see right away, all of a sudden it starts to change to this brown color. Okay, so that is a clue that a chemical change is happening. So we have a color change to brown. Now they're going to zoom in and they're going to actually mix it up together. There's a few other clues that I want you to watch for right after they finish mixing. Look very closely. You should have already seen one clue. Here's a second clue that's starting to happen now. And here's a third clue that just started to happen. I'm going to pause right there. The second clue I noticed was there was a second color change. What started as a white solid and a clear liquid all of a sudden is now a black substance in our beaker. Another thing I noticed was that there was the production of a new gas. So a new gas was created. It looks kind of like steam or smoke that starts rising out of the beaker. That's another clue that a chemical change might have happened. Now, there is potentially a clue for a physical change. One thing you might say is, well, it changed size, so that might be a clue that a physical change happened. Okay, that's fine if you want to write that down. So a change of size. Let's now look at the chemical equation for what's happening in this video. Our reactants are sugar and sulfuric acid. That's what we start with. Change, represented by our arrow, and we end up with carbon, carbon dioxide, water, and sulfur dioxide. So we started with these two compounds and we ended up with these four different compounds. So based upon this, did a chemical or a physical change happen? Well, a chemical change happened. Chemical change occurred because we ended with different compounds in the products than we started with in the reactants. And remember, if we could see the atoms inside, that means that some of the atoms are breaking bonds. The sugar is being broken apart, and then they're coming together to form new bonds and new compounds. Some of the carbon and oxygen atoms are coming together to make carbon dioxide gas that's coming off, and we can see. Some of the carbon is staying by itself as an element and is giving it the black color that we can see here. Okay? So this is an example of a chemical change. Let's move on to another practice problem that's slightly different. Our second practice problem says, analyze the sentence below, then write it as a chemical equation. Okay, solid gold was heated up until it melted into liquid gold. Okay, so let's start with our reactants on the left-hand side of the arrow. We started with gold as a solid, and then it heated up until it melted. So that's telling me it changed. So now we are into our products, into liquid gold. So gold as a liquid. It asks me to highlight my reactants in yellow, so everything I started with. Well, here I started with solid gold. And then highlight the products in green. Well, I ended up with liquid gold, so that's my product. Based upon this chemical equation, did a physical change or a chemical change occur? Well, I started with gold, and I ended with gold, so it must be a physical change. Because my products are the same as my reactants, or the same substance as my reactants. Okay. Remember, gold, still gold, even though it's melted, just means that those atoms have more energy, so they're moving faster. So no new compound was made. definitely a physical change. Let's move on to number 3. Now we're going to look at a model. So we can look at a model like this and we can decide if this represents a physical or a chemical change. So I start with these 2 yellow circles separate from each other. It looks like they're Cu, okay? And then there's also these 2 oxygen atoms, these 2 red atoms, attached to each other. This is my reactants. And then they change into, I end up with 2 molecules of 1 Cu and 1 O attached together, and then 1 Cu and 1 O attached together. So ask yourself, are there new compounds made in this chemical equation? Are there bonds being broken and new bonds being formed? The answer is yes. We started with 2 oxygens bonded together, attached together, and we ended up with an oxygen attached to the Cu. So that means a new compound was made, therefore this is a chemical change. I want you to explain in your own words how you know that's a chemical change. Go ahead and when you are done, move on to your check for understanding. You can pause the video. We're going to go through the answer key in one moment. At this point, you should be ready for the answer key. If you are not, pause the video so you can get your own thinking down on paper before we go through it. Number 1, you should have written a chemical equation that was wood changing into ash plus smoke. Wood should be highlighted in yellow, ash and smoke should be highlighted in green. And because of this, this should be a chemical change. A couple clues here. First, the products are different than the reactants. Okay? We ended up with ash and smoke. Those are different things than wood. Another clue was that a gas was produced. Smoke is a gas, and that's a new thing that's produced as we burn the wood. The second model represents a physical change. I know that they're a physical change because all that's happening is these atoms are starting to speed up. They're moving faster. There's no bonds broken. There's no new compounds made. Therefore, it's a physical change. Go ahead and total up your score. Okay? Out of 4 points, 1 point for the reactants, 1 point for the products, 1 point for saying the first one was a chemical change, and 1 point for saying the second model was a physical change. Move on to independent practice, and then make sure you finish up today with answering Mastery Check 3.2, Physical and Chemical Change in Edulastic. See you next lesson.